Good evening, everyone. So today's meeting has two parts. The first part is an introduction to text mining in R, and the second part, Linesh, the second teaching assistant, he's going to introduce you to the Kaggle competition. As you may remember, on the first day of class that was mentioned. So let's save the most interesting part of the presentation for last. So now, here is an agenda for the first part. I'm gonna introduce to you the backwards approach to text mining. We're gonna discuss what packages we can use for text mining, and I'm gonna show you how to load the documents into corpus. We're gonna go over the text preprocessing, terms frequencies, terms association, and I'll show you how to do the correlation plots, frequency plots, word clouds, and we're going to do the clustering, two approaches, k-means and a dendrogram, and there is a bonus for the first part, and it's going to be the networks of terms. And, of course, we're going to have questions and answers, and then a surprise. All right, so let's go ahead and get started. So what is text mining? Basically, the whole idea is that we're gaining insights from text. So is there a way to tell what this article is about without actually reading an article? So the analyzed text in question could be the social media posts, it could be emails, it could be job descriptions, and more. In this presentation, there are many approaches to text mining. In this presentation, we will focus on the back of words approach. In this approach, we are extracting a set of terms from the document. We don't care about the contextual meaning. We don't care about the order of terms. We don't care about the sentence structure. We are just focusing on the term count itself. And we want to use the counts to find the common topics. And we also want to use the frequency count to see which words the documents have in common. And for the purpose of this example, for the purpose of tonight's example, I chose the fraudulent email text, and this is the web page URL. The URL has a file with 25,000 emails, and I randomly selected 25. So I put each message in a separate file, in a separate text file. I deleted the message sender information, message ID, and so on. I just deleted that part. So this is what I'm trying to answer. What keywords are the dominant in fraudulent emails? Which words may appear together in the same fraudulent emails? Or are there different types of fraudulent emails? In other words, if I'm looking at the email, how can I know that it's a fraud? Am I looking for the specific set of words, or what am I doing, right? How do I do that? All right, so now here I listed the text mining packages, but it's only the subset. This is a web page where you can find more packages on natural language processing, but let's say this are the packages that we're going to use in today's presentation. TM stands for text mining. It's a main package that you use to read the data, right? Just the main data text preprocessing and so on, right? So you have the snowball, C, it's for stemming. Word cloud, it's a nice, beautiful visualization where each term represents the relative frequency of the size of which term represents the relative frequency of the term. So here, these two guys are for clustering. FPC is mostly for the hierarchical. Cluster, we're going to do this, we're going to use it for the k-means cluster plot. Then, most of you really like ggplot2 package for the visualization. Now, this package is for the correlation plot, but it's a little bit complex, a little bit tricky to run in the later R versions, but there is a workaround I'll show you. And the iGraph plot, this is for building the terms of network. This is not in your this is not in a work document for the assignment, But if you notice that in the course content for week 2, you see a nice picture. So today I'll show you how to do that, right? All right, so I'm gonna go ahead and I'm gonna share my screen. We're gonna go to RStudio from now on, and there is a script that I prepared for this demo. Share my screen. It's gonna take some time to come up. Okay, there we go. Here is RStudio, and this is a script that I wrote for today. So I'm not gonna run this because I already have the packages installed, but those are the packages that I showed you a minute ago, right? So you're gonna need to install them, and we install the package once. But the package is not available until I actually load it into memory. And to do that, I have to run the library command, right? As you may recall from the text mining introductory, the data mining, the RStudio rather, introductory demo last week, right? We use the library command to load the package in memory. And just to refresh, our package is a set of R functions, right? So there are two types of packages. There is a user library. Those are the packages that you install, and there is a system library. The packages that come in pre-installed when you install the RStudio. Now, very important, before I forgot, you need to download the latest R version for this exercise. At this point, it's 3.4.1. Next week, the new version will be released. But for right now, let's just download 3.4.1, right? Now, what I need to do in order to read the files, first of all, yes, I have to load this package in memory. Now, some of you asked me this question. Right now, I see this message: loading required package NPL. Keep in mind that not all messages in R are errors. In this case, this message is informative. It's telling me that there is something in my TM package that depends on NLP package, rather, not NPL, NLP. So basically, it's telling me that this package was loaded into memory in addition to TM package. Usually, you see the messages in red, but what I did was I went to the tools and I went to the global options and I changed the theme. I changed the appearance because I picked the theme that shows better when I do the presentation and that shows better in a recording, right? But you can always see these options here. You can always modify how your code appears. Here it is. So this is what I've chosen. So that defines the font and also the color. Anyway, so now let's set the working directory. Working directory is a folder where my R will attempt to look for the files. I have 25 text files, and I want R to be able to read them, right? So what I did was I created a folder, and this is what I call it, right? And this folder is on my external hard drive. So I have to run this command, set WD, to set the working directory. Notice that as soon as I run this command, the title bar of the console window displays what the working directory is. All right. So in addition, what I could do is I could go to Files right here. Oops, it didn't get refreshed. Usually when I go to Files, sometimes I can see what my working directory is here as well. Sometimes I can see, but I can go more, and I can, oh, look at this. Look at this. I select more, and then I select here, go to working directory. There we go. Right, so I selected more, and I selected go to working directory. So this is one way I can preview the contents of the working folder. See this? This is one way, right? But since you want to make your work reproducible, just not depending on the graphical interface, you can also get this information by running the commands. So get WD is going to show you what the working directory is, right? So now, very important, do you remember that everything in R is a vector? So what does this one means? This one means that this is the first element of a vector, right? I have only one element in the output. And this is the index of the first element in a row of output. Now, how do I list the files in the working directory? That's the next question, right? Here a dir command. Here I have several options. I can specify the folder path, or I can just use the dot. That's a shortcut. That means the current directory that I'm in. There we go. So now I see this. See this? I see these files. There are 25 totals. They look like not in order because it's trying to sort them by the file name, I think. But anyway, so you know that here, right? This is the folder where these files are located. Now I can also do this. I can do list. That's another way. Remember, Elena likes R because there is more than one way to do the same task. Now, these files are on a hard drive, right? There is something that I need to do to be able to analyze my data. And I'm going to build my corpus. I'm going to create a variable called docs, and I'm going to load my files into this variable. So this is a command to build the corpus. I'm going to run this here, and I created another variable called docs. And secretly, this is a list of 25, right? And see this? It's listing me the file that I just loaded. The message1, it's the name of the file, .txt. And here I have the file metadata, I have the file content. Content is actual text. And metadata is information about the file. For example, the timestamp when the file was created, the file name, etc. Right? What I could also do is I could run the summary command in here. Do you remember earlier you saw the summary command when we were looking at the numeric and the factor variables, right? The summary command also works to list the properties of the corpus. And in this case, it's listing the document and the document type, right? This is a text document. Okay? Now, ultimately, I could list only the properties of the first 5 documents. Do you see this? This is a subset, 1 through 5, right? I can just do that, right? So this is the first 5, and remember, it's ordering documents by, it's alphabetizing them by name. It's not ordering by this number here, so. Now, something else I can do is I can run the names command, and names command is going to list the document names. That's another way, right? There is also the length command. It's going to show me the number of documents in my corpus. So that's a corpus length, 25. Now, I'm wondering, how am I going to preview the text in my first document? I have to run the inspect command, but here is a trick. Secretly, see this is a list, right? So I have to have a double bracket in here. I have to have a double because this is a list of documents. I'm not looking at the first element of an array per se, right? I want to look at the first document, so this is a double bracket. And this is going to list me the text of the first document. So what I want you to do is here, I want you to pay attention here. What is this? We have this email address, right? Is it something we might be interested in? Just ask yourself a question, right? See how much white space is in here? What is this? Does it take space in memory as I'm going to analyze my data? So now, some of these emails have an URL address in them. There's a bunch of punctuation, etc. Right? And I manually removed the sender before, or rather at the time when I copied this, right? When I copied the text into the files. Now here it tells me how long my content is. Here's the number of characters. Now what I could do is I can run this command. It's just going to give me the metadata. It's an information about the first document. The time when the file was created, and the file number, and the language, etc. So now this is another command to show the text, but this shows a bunch of tags, right? Sort of like similar to what you see the new line character, instead of showing it as an actual white space. Now it says truncated. There is a setting that controls how many characters you can actually see, because you see only the subset, right? So now what we're going to do next is that, of course, we're not going to analyze our data as is. We have to do some pre-processing. And what I did for you, so here is a copy of the slides. I was trying to summarize. So if you go here, so here we stopped, right? Here, the information that I just showed, we load in the documents in the corpus, right? And I showed you how to preview the content. So now here, as the data pre-processing steps that we're going to do, we're going to remove the URLs, as you've noticed, right? We're going to remove the emails, we'll remove the white space, we're going to remove the punctuation, special characters. And also, I wanted to point out something. This is important. When I say removing numbers, I mean we remove numbers represented as digits, right? So if you have a number represented as a word, it does not get removed. Only if it's represented as digits, right? Then we have to have everything converted to the lowercase, because suppose that I have a word as Jesus removed, first letter uppercase, or if I have removed in all lowercase, I want to count both words as the same. When I compute my frequency counts, I want to treat it as a same term. We're going to remove the stop words. Stop words are English words such as the, to, the words that are used for the purpose of the sentence, to put words together in a sentence, or like articles. And we can remove the user-specified terms, right? And we can also do the stemming. For example, run and running, we want to count them at the same words. So now let's, actually let me show you the next, oops. This is the next slide here. So basically, R has some predefined text preprocessing operations. Some of them are predefined, such as removing the punctuation is predefined, removing the white space is predefined, but some of them we have to define the custom function. So what we're going to do is we're going to use the tmap command to run the preprocessing transformation. What I recommend is that I recommend you to read the help page for this command, and to open the help page, you put question mark and the command name, right? Hit run. So here is the help page. So I want you guys, I would recommend to read this. All right. So the command takes a corpus as an input parameter, and then you have to specify the transformation that you're going to run. For example, I can remove the white space, and or I can remove the punctuation, and so on. And here, this is how you get the list of predefined transformations. Remove numbers, again, this is only remove the digits. It doesn't remove the numbers that you spelled as a word. Here, remove punctuation. You have remove words where you can specify the word you can remove. You can do the stemming, and you can remove the white space. So to start with, I'm going to start by removing the white space, right? Oops. So before that, you previewed the first document. So let's see what's going to happen. I'm going to run this command tmap. This variable is a corpus, and here, this is a transformation. I want to remove the white space. There we go. So now, let's preview this. We run inspect command to preview. Notice that this is a drop in number of characters. 3524. And how many characters did I have before? If I scroll all the way up, see this? If you go, see this? I had way much more, right? So the size of the document got smaller because I took out the white space. Now, I could go ahead and remove the punctuation. But wait a minute. My document contains emails, right? But in my email, I have a punctuation. I have a dot, right? So if I remove the punctuation first, I'm in trouble. I won't be able to catch the emails. And I won't be able to easily identify the URL. So what I did here is that I created a custom function. I call it remove URL. And this is a regular expression. So basically, gsub, it's a function on strings. And it's going to take the pattern, take the specified pattern, right? This is a pattern. And it's going to replace it with a specified character. Usually I use a white space or just empty string. And here, X is going to be the corpus that you pass, right? So I defined the custom function, and this is the format for the URL, basically, right? And then I'm calling this function. I'm calling content transformer, and I'm applying this. There is, oh, this is an excellent question. Yes, some of you asked where there is a URL inside the document. It's highly possible. This text says I have an email, but if I go and preview each document one by one, I'm sure that I'm going to find it. I would have to preview all of them, but I've seen it. I've seen it, yes. Excellent question, though. Document text, very often, if it's a spam email, it may have a URL, something like visit this and this page to register, or something like that. Or send an email to this and this person. Okay, excellent, excellent. So now, let me run this. And when I run this function, you will see something. When I run this line of code, you'll see something added to your environmental window. I'm actually creating a function, right? It's in here, remove URL. Now I'm going to call this, I'll do this, and I wrote another function to remove the email. So take a look in here. This is your first document, right? You see this email. I'm going to remove it. So now I'm going to run this to create. And then I'm going to... So to get this regular expression, you could play around with the strings, or you can search online also. You would not believe how much you can Google. There we go. So now I ran this. And now what I have to do is I have to add this command. But since we were looking at the first document, I'm going to do inspect one. I'm going to look at the first document, right? Let me save this and let's take a look at the content. And if I did it right, I should not see an email anymore, right? There's no more email, it's gone. But there is other stuff I need to take care of. Do you see this? Periods, and I see a bunch of dollar signs, and I see these phone numbers that I probably don't care about, right? So we have some work to do. Now I'm going to remove the punctuation, and I'm going to use this transformation. This is available for me, and after that, I'm going, yes. Okay, let me see the question. Let me see the question. I'm going to get it, I'm opening the chat. For the URL, oh, excellent question. Yes, yes. In here, I'm only checking for the HTTP. You also want to check for HTTPS. Excellent. Excellent case. So we just had a question because here I'm checking for HTTP. And one of your schoolmates asked me a question. It's also possible to have HTTPS. Excellent. Yes, yes. So you could either create another function or you could add to this expression. You could add to this expression, yes. So I'm going to leave this part as an optional homework. Let's say it this way. I'm going to leave it as ungraded homework part. All right, excellent. I'm glad I answered the question. Now, I'm going to do this now. I'm going to remove this punctuation. I'm going to run this here. And I'm going to run this again. Looks like for the most part, it's gone, right? For the most part, I don't have any more periods and so on. Well, here, ellipsis means that my text is truncated. I don't see all the text. Now what I need to do, this is going to be my next step. I have to remove numbers represented as digits. And I'm going to run this. And let's change this. I'm going to change this to 1. Okay, and I'm going to run this. And yes, after this class, you're going to have a copy of the code, okay? So now, take a look at this. I removed the numbers. If I look through all of the documents, it's highly possible that what I just did, I did not take care of some special characters. There could be add, and there could be the slashes still that I have not removed. For this, you have to write another custom function. I call it toSpace. So what it's going to do is, if I have a special character anywhere, somewhere, it's going to convert it to a space. And let me run this. Now, this is how I use it. I put this toSpace here, and then I specify my characters that I want to remove. There we go. And again, and again. Now, yesterday, I received an excellent question from one of the students. It's this. Here, I'm replacing the special character with a space, so that adds a space, right? In the beginning, before I started, I ran the command to remove the white space. So the question is, should I hold on to remove the white space until after I replace these characters with a white space? Or should I do that in the beginning anyway? There is no right or wrong answer, and it does not hurt to do it twice. The reason I ran the stripped white space in the beginning because I wanted to cut the file size, right? And here I'm doing a cleanup. I want to remove the white spaces that were introduced by the substitution. And let me see another good question here. Let me see. Do you recommend removing an apostrophe? Oh, yes, apostrophes. This is an excellent question about apostrophes. There are 2 types of apostrophes. If it's a regular quote, it will be removed as part of the punctuation. There is also a quote that comes from Microsoft Word, and to be quite honest, at this point I have not found a way to remove it programmatically, so consider, before uploading the text, perhaps you can open the text in a text editor and do a global replacement. Replace that quote, the Microsoft Word quote, with the text editor quote. Right. So speaking of quotes, this is an excellent question. So let's say you want to remove something. Let's say you wanted to remove something. Oh, this is an excellent question to undo. Yes, guys, this is very important, and I should have pointed that out when I did an Arduino. There is no undo button. There is no undo button, but remember that you have a script. Your work should be reproducible. So the easiest way to undo the change is to rerun the script from the top. right? So the work should be reproducible. If I made a mistake, I should be able to rerun my script to recover what I had, right? So do you recommend removing all special characters? Well, this is an excellent question as well. In this case, well, it depends on the purpose of the study. For the study, yes, I want to remove because, well, first of all, the reason I don't care about the punctuation is because the approach that I use does not preserve the order of words in a sentence. It does not preserve the sentence structure, right? So do I care about the punctuation marks and special characters? I don't. Because in this analysis, I'm not looking at the word context, right? So that's the reason. It all depends on actual studies that you're doing, right? So you're not looking, perhaps suppose that I was analyzing how many times the email address appears in the text, then I would have used a different approach, right? So now here, I'm going to just remove the white space that I introduced, right? All right. So this, oh, we already did that, right? Let's go down. Here, so we remove the special characters, and I'm calling this function for each one separately, right? Now, if you may have used the older R version, this piece of logic was done differently. So this piece of logic is not going to work in the older R version. It was done differently. And also, after loading the data into corpus in the older version, you could not run just inspect command like this. You would have to loop through all the documents and convert each document to the character. So this is another main difference in this R version. So we did that. Now I have to convert to lowercase, right? Because I don't want to count. See this? Like here, I have one word, right? Did in the lowercase. If I have another occurrence of this word in the uppercase, it will count as two separate words for me. But that's not something I want, right? For the purpose of this exercise. So I'm going to run this to lower, and I'm going to preview. The next step is a stop word. And here, this is a challenge because this relies on a predefined list of stop words in a dictionary, and there are different types of dictionaries that are available. I'm going to use two to remove as many stop words as possible. There is an English and there is a smart. Okay, so I'm going to run this two here. Let's do this. Let's run. So I expect words such as is, to be gone, right? So let me run this here, and then I'm going to run the inspect command, right? Do you see that? Some of the stop words got replaced with what? They got replaced with the space, right? They got removed. Yes, very important. Something else I wanted to say. The text preprocessing that we're doing, it's done in memory. This is not done to the actual file stored on your disk. So, at any time, if you think you may have done something wrong, you can always rerun the script from the beginning, just reload the files and so on. The changes I'm making here do not affect the actual copy of the file on the disk, right? It's only what's in this memory here. Now run, and I'm gonna do another inspect. Yes. Is it possible to add, hold on, let me see. Yes. Is it possible to, excellent, yes. You can remove your own stop words. And in fact, this is one of my, what I did was in the presentation, I put together a list of questions and answers that a student had in the last semester. And in fact, this is one of the frequently asked questions. The question is, how do you remove user-specified words? So this is what you do it. You're going to do docs, tmap, remove docs. So this is an example of how to remove two words, data and study. See this? So this is an example of how you remove your custom, you specify the custom list of words to remove. And I'm going to give you the copy of this presentation. But I put together this from the last semester and some questions that some students already asked me, right? So now let's go back here. Yeah, but this is excellent question. And now I'm going to clean this up. Yeah, I'm going to clean this up. I'm going to remove the space that I just introduced, right? Now what I'm going to do is stemming. And this is also based on a predefined dictionary. Well, sometimes some students say that they expect a better result from this, but, well, if something you expected to be removed did not actually get removed. Oh, yes. Oh, excellent, excellent, excellent. One of you asked me why I ran 3. Well, I can run 1. But basically, what I did was the command I ran here, it applied to all documents in a corpus, right? This transformation that I ran applies to all documents in a corpus. So I can preview more than one document, right? I can preview the third one, right? It does not matter. But basically, the reason I want to look at the same one is because I want to show before and after. I want to see before and after, right? Before and after. So I recommend you stay with 1. Oh, no problem, no problem. No. I'm so glad that somebody pointed that out. No, this is an excellent question. I would rather see people ask than yeah. All right. So here I applied the stemming. This may take a little bit of time to run. So while it's running, let's see if I missed anything in the slide. So let's go back up. Okay, so we were here, right? So here I spelled it out for you. So this is the gsub is a pattern matching function, right? So I called it to space. You're gonna have the slides afterwards, and our next thing is gonna be document term matrix. We'll get there. Okay. Is stemming required? For instance, if I'm trying to find how often the word customer is frequent. Oh, this is an excellent question. If I take the word called customer, right, and if I cut the spam, I get custom, which changes the meaning of the word. Excellent, yes. So that's what we would expect to see in a paper, because this approach the bag of words approach does not consider the actual meaning of the word. That's right. We are changing the meaning of the word. So there is a pro and con in here. Yes. I would think it would depend on the purpose of the analysis. Exactly. There is no prescription for what is right or wrong. What we do depends on the purpose of analysis. Exactly. And that's something that you will explain in your experimental design. Yes. All right. So now we're going to run inspect command to preview, right? So now the next part is fun. Document term matrix. So now we have to have a way to calculate how many times each term appears in the document, right? In each document. I have a set of documents, and I'm going to build a matrix. And the matrix is going to track, it's going to look like this. Every single row will represent a document. This is a subset. And every single column is going to be a term, right? And every cell is going to show me how many times a term shows in a document. Like, see, the second term appears 5 times in the first document. It appears 3 times in this third document, right? And so on, right? So what I'll do is I'm going to build a matrix called M. And let's go ahead and to do that. First of all, I have to run this function. I have to apply this function on my corpus, right? It takes corpus as an input, right? And let me see what's gonna happen. So DTM, this is my list, and it's telling me that I have 25 documents, and here is a number of terms. And the sparsity basically is telling you the percentage of 0 cells in a matrix, and I'll show you what I mean. So that basically showing me the percentage of the. Notice that here, if I go back to this picture, if the number is 0, it means that the word does not appear in a document at all, right? So we want to look. Sometimes we look at the percentage, right? And sometimes, well, what I'll show you, we want to look at the most frequent terms. So we want to eliminate sparse terms. We'll get to it. Now, what I'll do is here, I want to calculate the frequencies of terms, how many times each term appears in all documents. So this is call sums. I run the call sums, and this as matrix is going to, what this part is going to do is going to build it as a matrix actually, right? So if I do this, let's take this part here. If I do this, and if I just run a view command on this, right? If I run a view command on this, take a look, what is this? This is actually a matrix, right? This is a matrix. And there is a function on the matrix called callSum, and what callSum does is it will add all numbers in a column, right? It will add all numbers in a column. But all numbers in a column is how many times the term appears in all documents. It's an overall frequency of the term, right? So this is what basically I'm doing here. And here I'm going to list a vector of terms and how many times each term appears. Now the list is huge. Let me preview the first term elements. And the problem is it's not sorted, right? I don't know which terms are the most frequent. So suppose that I want to see the 15 terms with the highest frequency. I want to see the dominant term. One way to do it is that I can create another list and I can sort it. I can sort the frequency list by the frequency, and I want to do it descending. Minus sign means descending. And remember that from the last class, from the class on introduction to R, this is a conditional subsetting, right? So I'm taking the elements in the same order as they will appear after sorting. See, the minus sign means I want to sort them descending, and I want to go by frequency. There we go. All right? And now I'm going to take this sorted list, and there is more than one way to preview the first 15. I can do the subset like this, right? I can do that, and notice that it's sorting by the counts, right? There is something else that you could do, and I'm going to leave it for you as homework. You could say, okay, suppose that I have two terms with the same number of counts. You could sort it also by the term itself, right? You can add the second criteria to the sorting. So this is going to be your homework, something you want if you want to play with it, right? Ungraded. Now here, another command. This is your friend command head. It's going to show you, by default, it's going to show you the first 6, right? The top 6 dominant terms, right? And if I specify the second input parameter, I can do the top 15, or the tail command is going to show me 15 least dominant terms, right? So now here, this command will show me the number of distinct terms, because what I'm doing is I'm taking the frequencies vector and I'm going to take a length here. Now, do you remember what I did earlier here? I did this, right? I ran the call sums command and I did this as an input here. Now what I'm gonna do it a little different. I'm gonna create a variable and I'm gonna call it M. And I'm going to actually set this value, right? Instead of plugging this part in here, I'm just gonna create a variable. I want to store it in a variable. I just want to do it this way now, okay? So that way I have less repetitive typing. Here I can display the number of terms, because remember that's a matrix, right? Here, this is a matrix. So now I can show the dimension of this matrix. This is going to show me the dimension. The first dimension is the number of documents, and this is the number of terms. View M, it's going to show you the tabular view. So this is how your matrix looks like, and it's going to take a little bit of time to load, but, right? And on the slides, I put a subset because, well, it's a large matrix. All right, so now here I can also preview the subset. Do you remember from last class, right? I showed you how to do the subset of rows and columns for the data frame. The same approach works for the matrix, right? So what I did was I took first four rows, and I took the first two columns, where each column is a term, right? Here I can see how many zero terms I have in the matrix. So this is a number of cell entries. So here I'm going to have the number of cell entries in the matrix. What does zero mean? Zero means the term is not present in a document. All right? So secretly, I'm looking at analyzing the matrix sparsity. I'm showing you how to calculate the percentage of empty cells. So to do that, first we're going to look at this. Do you remember from last class we did the function, we did any? So if I put any, m equals 0, double equals, it's going to return me if the matrix has at least one element of 0, right? But this part here, what this part will do is, well, I did not want to put this, okay, because this, what it will do, oops, let's do this. So basically, it's only, I was unable to display this, it's because the number of terms, it does not fit, the output size is above the allowed limit, so I won't be able to show you this part, but what it's doing is that it's looking how many elements in the matrix I have that are equal to 0, and it's going to return the count, because it's going to go through all elements here, and if it's a 1, it's going to do false. If it's a 0, it's going to do true, right? And then it's going to count how many are true. And here, this is a trick. I want to get the total number of elements in the matrix. There is more than one way to do it. I could multiply the number of see here when I did this, right? To get the number of elements in the matrix, I can multiply 25 and this number. Alternatively, I'm just checking how many elements are equal to or greater than 0. That's just one way, right? And here, I want to see how many percentage of cells are empty, right? So this is what? This is the percentage of empty cells. This is matrix sparsity. And if you remember, this is this number. Oops. It's this number. I just showed you how to obtain this number. We take the number of matrix cells that are 0, right? We multiply it by 100 and we divide by the total number of cells in the matrix. Well, I just showed you how this number is obtained. And here is the total number of terms, right? Number of documents. And here is just showing you the number of non-sparse entries. The non-sparse entry means it's a non-zero entry, right? So I could just change this greater or equal to greater, and it's going to give it to me, right? if I was going to calculate this, I would have to do this. I'm going to have to take this out. And it's supposed to give me that number. See? It's going to give me this number. Alright? Now what I can do, so see this? It's my matrix. Right? This is my matrix. What can I do with it? Let's see what I can do with it. Can I look at which terms appear in the same document? Can I look at which documents appear together? Right? I can do a bunch of stuff. So now, let's do this. I want to list the terms that appear 25 or more times in all documents. Can I do that? Of course I can. Find frequent terms. And I pass the matrix, and this is it sets the lowest frequency. So the term must appear at least 25 times. There we go, right? Now, this command, this is different. I want to find most frequent terms. What this will do here, it will find the 5 dominant terms in each document. This is going to work at the document basis, okay? So it's going to list the document, and it's going to list me the term and the frequency, right? Here, I'm going to do the term frequencies for the first document. Term frequency for the first document, right? What I could do is I could further play around with this command. So this is one way you can do in your assignment. Go beyond examples in a classroom. You can run this command here, and then you can go, I see this here, control list. So over here, I can add more parameters than Elena used, right? I can use more parameters in here. Let's see what I could use to make this command more useful. Is there anything I can change? Of course I can. Now I can say, okay, let's look at the words that are less than 4 characters, perhaps, right? So I'm going to specify the word length. Let's see what this is going to do. 4 or less characters. Negative infinity means that just less than 4. That's what it basically means, right? So I'm displaying the term frequency for each word in the first document, and the word has to be the 4 or less characters long, right? So what I do, I would just have to read this and pick something up, right? Something that Elena did not do. Now, here, I just want to say the words that appear 8, 9, or 10 times. Can we do that? Oops, I made a mistake. Oh, no, I did not. I did not make a mistake. I'm counting the length. Here, I'm not looking at the frequency. I'm looking at the length. It's the number of letters in a word, rather. See? So here, I'm looking at the number of letters in a word. I'm not looking at the frequency of a term to determine what gets displayed, right? Now, here, I can remove the sparse terms, right? Because I'm going to do some analysis right now. But my goal is to identify the set of words that appear in most of the fraudulent emails. So if the term appears only in one email, I just want to omit it for the purpose of this specific analysis. Let's say the matrix cannot be more than 80% empty. I want to keep the terms that appear in at least 80% of the document, right? So this is what I did here. 0.2 is 1 minus, right? 80% is 1 minus 0.2, so I have to put 0.2, right? Because I want to make sure that I have no more than 0.2% of the documents that don't have the certain term. So let's do this. I created a new variable and I call it DTMS. It's going to be something similar to, it has similar structure to the matrix here. The difference is that I'm going to have less terms. right? Like, see, I may have some terms that may appear only in 1 or 2 documents. Those are going to be cut out from analysis, right? So now, what I did here, I can display the matrix properties again, and here it's just showing me the number of terms, and again, there is no right or wrong answer. You would have to play with this number. You pick what works for you, and the reason I picked this number is because it has to do with some visuals that I'm going to be demonstrating in the upcoming code, and I wanted you to really show the layouts. I wanted to show you something, so that's the reason. But in reality, I probably want to look at more terms than this, but let's just keep it like this for right now. Now, here, dim names, this will return the names of terms. It will list the terms in this matrix, right? I have 11 terms remaining, but I want to list what the terms are, right? So here, this will list the terms and also the document's names. And this is another way to do that, right? Now here, suppose that I want to list the terms only, and I listed more than one way to do that. Because see that there are 2 dimensions, right? I'm interested in the second one, which is terms. This is another way. And yet there is another way. And then another way, right? There are several ways to get this information. The output might look slightly different, but more than one way to answer this question. Now, here I want to look at the association between words. I have 3 words: money, bank, and success. I want to list all terms that are associated with these 3, but I want to keep the term, I want to list the term only if the correlation is at least 0.75. So this is what it's going to do, right? It's going to run find association for me. There we go. So basically, see this? This is probably manage. Yeah, this is manage. It lists this with the word bank because the correlation is 0.77. It's above the specified threshold. Oh, take a look at this money and open. So maybe somebody is trying to get you to open the bank account or something like that, something along that line, right? So, right? Now, here, you're going to run these 2 lines of code. This package to generate the correlation plot, this package is not in the CRAN repository. What this will do is, this is a script located online, and the source command runs the script at the specified web page. You're going to run this, and you're going to run these 2 commands. Then you're going to run the library command to put it in memory. Okay, now see this message? Some of you may think it's an error. No, this is just an informative message. And this may take some time to run. So I have to be a little bit patient here. Okay, now, see this? I got this message. It means that this package was loaded at the same time because I'm going to be doing something, right? The package that I'm using has a function or something that depends on a grid package, right? Now I'm going to build a beautiful plot. And what I want to do is, I want to plot the frequent terms. Do you remember we looked at find frequent terms? And this is a minimum correlation that I want to keep, right? And weighting equals true means that the thickness of the line should be proportional to the correlation between terms. So now I'm going to run this. And we're going to need to wait. Okay, here it is. See this? So now what I said here is that I want to show the terms that appear at least 40 times in all my documents, right? And notice here, I'm back to DTM. I'm not using the matrix where I removed the sparse terms. I'm not using it. I'm back to this document, original document term matrix. So here, right, I want to draw a line. Oh, is 40 time? Oh, 40 time together. Excellent question. So I had a question. The question is, do I pick the terms that appear 40 times in a specific document, or it's an overall count? This is an overall count. So if the term appears at least 40 times, it's going to be listed in a rectangle here. And if the correlation between a pair of terms is at least 0.2, they're going to be aligned. Right? It's going to be a line here. Yeah, excellent, yes. And how thick is the line? Well, it's proportional to the correlation. That's what it's going to do. Now I'm going to change it. I want to drop the frequency threshold. I want to see more terms. And I want to say that draw a line only if the correlation is 0.3 or above. There we go. Right, so this is slightly different. I have some terms that I did not see before, probably, right? Now what I could do is I could play around further. I keep 40. I want to see the terms that appear 40 times at least, but I want to see a line only if correlation is 0.4 and above. So see this? I see the term because it appears at least 40 times. But I don't see any line because there is no another term that appears at least 40 times that is correlated with this term with a correlation 0.4 or above, right? So here there are several input parameters to play with, right? Low frequency determines which terms appear. This one, correlation threshold, determines if you see the line, right? And weighting determines if the line is proportional, the thickness of the line, if it's proportional to the correlation. Now here, this is a different plot, and this is a ggplot2 package. Let's load it into memory, and this is just one way to build the frequency plot. So I'm creating the data frame in here, and of course, if I plot all terms, the plot is going to be cluttered and impossible to read. So I'm going to say let's plot only the terms that show up at least show up more than 25 times, more than 25, right? And this is, I can put my labels on the angle. This is just the plot cosmetics, right? And I'm going to wait a little bit, and the plot will show in the plots. There we go, right? So here are the term, and the cosmetics is how this here appears, right? I wanted to show it slanted under 45-degree angle to make it more readable. And the bar height is the word frequency. So you can see money is the most dominant term in fraudulent emails, and the next one comes assist. So more likely, if you receive the message, something like it has the word assistant and money, it's highly possible that email could be fraudulent. Maybe not. We can't conclude it, but you see that? It's frequent term. And also the foreign, I'm not surprised, because foreign font, very often we get fraudulent email with these terms. Now, here, the word clouds. What I want to do here, I want to show all terms that appear at least 5 times, right? But the problem is, see this? Now it keeps drawing, but you're gonna see. Now you're gonna see something here. It keeps on going. At some point, you may see something that looks like a warning. That all terms did not fit on the screen. If you get this, don't worry. Don't spend time on fixing it. This is quite normal and quite possible. It's just a warning. right? So this takes some time to run. So notice that the size of the word, this is a relative frequency, but it does not tell us what the actual frequency is, right? We don't know if it's 100 or if it's 1,000, and there is no way to do further math on this. There is no way to physically go in and sort this, right? Is there? No. It just randomly places the terms for me, right? So it's still running. What I should have done is I should have increased this number here to reduce the number of terms, but while it's running, let's go back to slides to make sure that I cover everything. So here, I'm just showing you what we went over. I sorted the terms, descending by the frequency, and I'm just listing the 15 dominant terms. Here is how to do it. I'm doing this. I'm using the ggplot to produce this frequency plot, right? But you have to remember that you need to put this library in the memory, right? Because if the package is installed, it does not mean that it's available to use until you put it in memory. And here we went over these three functions: finding frequent terms, most frequent terms, and this term frequency. And you're going to have a copy of these slides after class, right? And we went over different ways to show the terms in the matrix. So let's go back, see it. It's done. There we go. So what I was talking about is that it's highly possible that you may get this warning, right? And the reason is because I have too many terms. See this? It showed me that some words, they don't fit on the page, they were ignored. So I can do is I can increase the size, I can zoom in, or I can just prioritize. I can leave. I can keep more frequent terms and leave out the least frequent, right? What I could do here, I can remove the sparse terms. Let's remove the sparse terms. And I want to make sure that the data has no more than 70% of empty space. So I'm going to run this. And now, here I can just look at here in this variable, I'm going to store the frequencies. But now I'm going to do something fancy. I'm going to use colors. Yeah. So here I define the color, right? And I'm going to build the word cloud. I'm going to use the color. And I'm going to say I want to show only the terms that appear at least 10 times. I want to list less terms this time. There we go. Now, what I wanted to point out is that when you run the command again, the word cloud image will appear differently, right? If you want it to appear the same time, you want it to have the same appearance, you would need to run the setSeed command, right? SetSeed. Well, I'm not doing it here, but in general, if you want this to be reproducible, do you remember back from the data mining? SetSeed, right? Yeah. So that's a command you would use if you wanted to, yes. Oh, why rotation? Okay, the rotation determines how, take a look at this. Do you see this? How I want to put my words vertical like this. It just basically determines how often the angle changes, okay? Yes. And this is something else you want to play around with. So if you are like me, if you like the graphics, right? If you like to, in fact, I've been saving, I have a certain sort of, like, so to speak, collection of these different images that were generated in R, right? So now, and you see some messages, it's because some words did not fit on the screen and they won't be plotted. I think part of it is that I have a different range of frequencies. That could be it. But anyway, this is not an error message. It's an informative message, right? Now here, so we did the word cloud. The next thing is k-means clustering. As you may recall from the data mining class, k-means clustering is an unsupervised method. So it finds we're going to find the groups of terms, but each group does not have a predefined label, right? It does not have a predefined label. We need to explicitly specify the k-value, number of groups that we want to take, right? So first thing I'm going to do is I'm going to remove the sparse terms. Here, I'm going to calculate the distances. I'm going to use the Euclidean method, right? So I'm taking the matrix, transpose, and calculating the distances. And now I'm going to run the k-means clustering method, and I'm going to pick k equals 4. There we go. And now k-fit output is huge. This is huge, right? So here I'm showing you how to take a portion of this. You put k-fit, you put a $sign, and then you put size. This is going to show you how many terms are in each cluster, and we're going to get to cluster plot in a second. But here it is, right? It shows me the number of in each cluster. Now here, within. Basically, each cluster has a center, and I want to look at the sum of square differences between the terms and the cluster center. And my goal is to minimize, I want to minimize the sum of distances within cluster while maximizing the sum of distances between, right? So I want each term to be closer to the cluster center. So let me go ahead and I'm going to run this. This is how to show the different parts of the output. And the total sum of square distances will always be the same regardless of k. Now, I forgot to plot this. Some of you, I got this error. Why did I get this error? And it's actually one of my, the slides, if you notice it, there is a troubleshooting section. So I put some errors that the student got from last semester, and this is one of them. It's because Elena forgot something. And what did Elena forget to do? She needs to do this, library, right? And I have to load the package in memory, right? So this is what I have to add. This is the reason I got this error. I have a package installed, but it's not available. Let's see. Error, Elena does not know how to spell, right? The package name is cluster. See this? So, Elena needs to learn how to spell. There we go. It's taken some time to load the package, and then after that I'm going to run this. So what the k-means fit into? Oh, excellent question. Sarah just asked me an excellent question. Where I have to put an output of k-means? Depends. If you have a small diagram that you're discussing, like for example the cluster plot that I'm about to show you, and if it's a small plot, you may want to put it in a text where the plot is discussed. If it's an output small like this, like within betweens, that goes in the text. But if it's something like pages or pages and pages of output, that goes to appendix, right? So I hopefully that answers this question. Yeah. Now, take a look at this. So you got these properties. Okay, sure. And now, yeah, let's run this. There we go. Well, it looks so nice because I eliminated sparse terms. I played around with it. But some of you may say it doesn't look nice. You have options. You can do, there is a part of an output, part of the k-means method has part of an output that shows the cluster membership. I believe it's this part, cluster. The cluster part of this output is going to tell me in which cluster each term was placed. So this was a question I had last semester, right? So if I do this, right, cluster, this is going to show me the membership. There we go, right? Okay. so not a big deal. Now, here, this is a refresher from Data 350 class. How do we know, how do we estimate the best value of K? One way to do that is to run this is an elbow method. I want to calculate the sum of squared distances between clusters and within cluster. And I want to do it for different K values. I just decided to do it from 2 to 15, and I'm going to plot. You're going to have a copy of this, right? So I'm calculating between. So here, basically, I'm taking a list, right, and I'm initializing it. I'm initializing the list, and here I have a loop here, and each element, I'm going to loop through each K value, and I'm going to compute the distances. Remember, this takes the between as part of the output, right? So I'm doing this, and now I'm going to do the plot here, right? And now I'm going to do the same thing for the distances within. And here, see this line command? Line command is going to draw the line on top of the existing plot. And then you want to look at the bend point, right? You want to look at where the bending point of the plot is. That's probably your best K value. We did the K-means, and there is another approach, Dendrogram. So here you want to have both. You need cluster and FPC. You need to load both packages into memory. And now, okay, we're going to remove the sparse terms here. Something I want to point out that the dendrograms may work well when you have a smaller number of terms. When you have a large number of terms, dendrogram gets really cluttered and difficult to read, so keep that in mind. Now here I want to use the Euclidean distance. Now I'm building the model and I'm going to plot this. There we go. Right? So this is my dendrogram. And again, I did a little bit of homework. I played around with this input parameter. I just played around to make it look nice. So, and I did it for the presentation purposes only. Now what I want to do is I want to add the borders around the clusters. Plot new is going to start the new plot, right? Now I plotted my dendrogram again, and this is a group cut tree. This is what I use, and I want to have 3. I want to put 3 borders. I'm using K equals 3, just decided. And I want to use different colors. I like colors. There we go. Right? So next part, this is for paying undivided attention. This is Yelena's bonus, and then later we're going to have something fun. Okay, so here is a library called iGraph. This is a library that you need. Up to now, we were working with a document term matrix, right? Now instead, we're going to look at the term document matrix. So if you go up here, I'll show you what we're looking at. See this? We're going to look at this, where each column is going to be the document, and each row is going to be a term, right? So now, instead of looking at how many times the word appears, we're going to look at if the word is absent or present in a document. This is what we're going to do. But if you might be curious what I'm talking about how to plot something like this, right? Something similar to what you see. You see a picture in Week 2 course content. And now I'm going to show you the secret how to do this. So here it is. This is a high-level steps. I have the term document matrix. Here, each column is a document and every row is a term. And here is the frequency count. I'll have to apply the logic where I set each non-zero entry to 1, because I don't care how many times the word appears. I only care if it appears, right? Now I need to know which terms appear in the same document and how many times. So what I have to do, I have to take this matrix and I have to multiply it by its transpose. So this is what I'm going to get, and I'll show you the code, but I have to explain the high level what I'm doing. So I'm going to multiply the matrix by the transpose. So that's going to give me a matrix like this. See this? Where I have terms listed on a row and a column, right? So the second cell tells me how many times the word assist and conduct appear in the same document, right? And so on. This is how I read it. Then I have to build the list, the paired list. For example, this is going to be my edge because the assist appears together with the word contract, right? So I've got an edge, right? Behind the scene, the word assist should have an edge to itself, but we're going to eliminate it, and I'll show you how, right? We're going to run a little step to eliminate it to make the graph less cluttered. We're going to have to set the labels for each vertex, and we have to set the layout. There are different types of layouts, right? So that's a lot of fun if you like the graphics. But let me show you how I do it, and you're going to have a copy of this. So here I'm building the term document matrix, right? Now I'm going to remove the sparse terms. I'm converting it to a matrix, right? Here what I'm saying is that if the entry greater or equal to 1, I'm going to just set it to 1 because I don't care how many times the word appears. All I care is that it appears. Okay, now here I'm going to build this. This is a multiplication operator, and this is a transpose. I'm doing multiplication here. And the term matrix, it's going to be what we looked at in the slides. It's going to be this. Now, I have to build the adjacency list, right? I'm taking this matrix, and I want to do undirected graph. So here, now, the reason I run simplify, because if I don't do that, I'm going to see something that you saw today on the first slide. This guy right here, see this? I want to remove the loops to make it the graph less cluttered, right? So that's basically what this simplify is going to do. And here, I'm just adding the labels. I'm setting the vertex label to be the vertex name is a term. And I'm sorting the degree. The degree basically is the number of edges emanating from the vertex. And here is your favorite set seed command. And now what I'll do is I take this here that I built. This is a layout input parameters. And here is one of the layouts. And I want to change the vertex color, right? So as a homework, you can look up this function in a help, right? You can look up the help system, and it's not on TMAP, but you would need to look at the iGraph package, and within the iGraph you have to look at the plot for iGraph, or you can also look up the layout and see what it does, right? But I'll tell you, what you could do is you can change the vertex color, you can change the vertex size, and you can change the shape, right? So I'm just showing you the different layouts, different things you could do. This is just the fun part. This is just for fun, right? And I have to go to the plot, see that? And so on. So that's basically what it does, right? So now I'm going to go back to the slide to make sure that I covered what I wanted to cover, and that it's going to be linear storm. So we covered this part here, and very important part that's left is troubleshooting, and we'll have a slide here. So last time your schoolmate reported this problem. You see this one plot on top of the other. So to do that, you want to run to fix it, you want to run plot new before creating the second plot. Dev off is an option, but the dev off is going to delete all plots that you have created. So This is a problem, right? You see one plot on top of the other. Before building the second plot, you put plot new. That will solve this specific problem. Then another student reported this. Here is my cluster plot, but I cannot see the axis and the label. See the word cluster got cut off? This is a solution, right? Oops, it's a typo. So what I have to do is I have to set the margin. I have to set the margin of the plot. This should do it. That will solve this problem, this specific. This was another student reported. I ran the stop word command, and the stop word did not remove this whole word. She was trying to remove VR, but it left this piece here. It's because you need to remove the punctuation before removing the stop words, right? That's one thing. Here, this is an issue that I talked about, right? This error message is because your schoolmate, or whoever ran this, or today it was Yelena, she forgot to load the package in memory, so that's what it means. Now there are additional some question and answer. So this was an excellent question, and I'm glad that someone asked it earlier today. This is how you remove the words that are not part of the dictionary. This is a user-specified word. Excellent. Now, some of you may need help with finding the data set, so go ahead and check the course content week 2. I put some data set that you could use. You don't have to use from the list, but it's just a suggestion. Now, some of you ask what's the paper length requirement. There is no specific length requirement, but you want to address all the key points and be creative, right? And you want to make sure you stay on topic. Now, this is a good question that I received this week by email. In the walkthrough, and by the way, speaking of questions, it would benefit everyone if it's a question like this, like what you see here, post this in a classroom, because these questions, the one I just presented, they're good for everybody. So here, in the walkthrough, we remove the spaces before replacing the special characters with spaces, right? Well, you can run the same command more than once. You can remove the space to start with, and then you can do it again to remove the introduced spaces while applying other operation. And here, the paper should follow APA format, yes. Now, I added some free text mining books. All right, so I spoke long enough, so now it's going to be Linesh's turn, and then we're going to have question and answers. Let's do that. So, Linesh, I'm going to stop sharing my screen. Are you still with us?
Yes, I am.
Okay, so I'm going to give you the right to present. I'm going to stop sharing. Are you ready to present the
Sure. Yep, I'm going to share my screen.
Yes, I'm going to give you the right. Do you want to change presenter? Yes. So guys, you have been waiting for this moment. Linesh is another TA for this course. So he is with us now. And from now going forward, he is with us. All right.
Okay. All right. Good evening, everyone. And as Lena mentioned, and I know, I think the last time I missed the first webinar, so due to unavoidable circumstances, I was not able to join then, and also I'm kind of joining late, but I know you were in very good hands. So thanks, Elena, for helping out the students in the meanwhile, and I know you've been really in helping out on my behalf as well, and but I hope I'm able to cover you for the next few days, and I know Professor Patrick as well, kind of helping out. So thank you so much. That going forward, I will be kind of there for both the sections in helping out, and of course will be introducing myself. But in the interest of time, I'll go right into the Kaggle competition. So before I go there and kind of talk about it, let me ask. I know there are several of you here. So my question to you is there anyone here who's never heard about Kaggle computation or not participated in a Kaggle computation before? Anyone who's not who has not heard about Kaggle competition or not participated before? Okay, I see one person who has not participated. But Vinay, have you heard about it? Okay, so I see a couple of folks. Okay, so I believe most of you have heard about Kaggle, but some of you may not have participated. And then that's fine. So, okay, I'm glad that, most of you here have heard about Kaggle competitions, what it is about. So that's a great start, guys. And so I'm glad that, you're aware that, Kaggle competitions are really, one of the areas or one of the websites which, provide a good quality of competitions, and then where, it's, one of the areas where, especially, during our data analytics programs, or even after that, a lot of folks would want to practice their skills, and including myself, been, trying to do that during our data analytics programs. Even while I was in a part of UMUC data analytics program, even after that, tried my hands on to on many of these competitions. So I'm glad that the UMUC has kind of really started with putting up Kaggle competitions as part of the coursework. So really thanks to our data analytics department and our and everybody in the department to kind of start, and especially um, Dr. Elena to kind of start with this program with this competition. So with that, what you would see very soon is in your discussion board also a particular link that will help you to get on board with this competition. So a link, there's a competition that's being set up especially for this course, for this class. And so when you go to this link, there's a competition that's being set up, which will be exactly, so once you go to this link, you'll come to this site here on Kaggle.com's website, which would say, University of Maryland, University College, UMUC Data Analytics Data 650 competition. Now, this is exclusively for this course and for this class. So please do not share this link with anyone outside this course, outside this class, and you just use it for yourself. Additionally, I would suggest that you use your UMUC email address if as and if possible, so that we are able to track your student ID as much as possible. Only if you already have an email account here or with Kaggle, then in that case you may be able to use that. But I would strongly suggest that you create your account with the UMUC ID, and I'll show you how you could do that. Okay. So once you get the link, you would basically come to this page here. So with the link that I will kind of send it out and share it on your discussion board, you would come to this site here. And once you're here, you can click on this create an account. As you can see on my screen here, right at the bottom of the screen, you'd see this create an account. And once you come to this link, you can just create an account. And at this point, basically, and once you click on it, um, you can start filling up all this info, manually create an account, and you can start filling up all this information here about your UMSC, all the information about your username, your display name, your email address, which could be your UMUC address, and your password, which could be anything. It doesn't have to be your UMUC password. This could be any password that you want on this particular website. So once you're done, you basically come to this particular, website here, the Kaggle website, and at this point, it would say, okay, do you want to join the competition, right? So at this point, you would say, okay, I would want to join the competition. So the first thing, once you click on join competition, it would say, you will have to accept this, you'll have to accept the competition rules. And you can read through the rules here, right? Okay. So what are some of the competition rules? Just to give you an idea, some of the competition rules, okay? Quickly go through them. First is the model building process. You must train your model using the data which is available through this website, which is the carstrain.csv file. There's a file that has been provided. You have to train your model using this file. You may choose the data that is available in the cars test data set as your test set, okay? So while you're building the model, you can use this test set for any of your testing purposes. There's the remaining data. There's also called a car submission data, okay? There's a third data set that's been provided for your submission. That has to be used for the final submission, okay? Now, failure to follow this rule will lead to rejection of your entries, okay? You can make more than one entry, and that rule has also been, mentioned here. There can only be one account per participant, okay? So that you would not have multiple, accounts here, so just sign in with only one account. There cannot be private sharing outside teams, so please do not share your code amongst each other. That's not going to be allowed. There cannot be any team mergers. You may see that the other competitions within Kaggle, if you have already participated, you could form teams or you could have mergers. Not in this case. Okay. There are no maximum team size. You cannot form teams with each other. There's only individual competition. And there are no submission limits. So good thing about this is you can try this out multiple times. You can actually try this and submit your code, submit your model 10 times per day, and you can at the end you can select up to five final submissions for judging, right? And then why do you say five? And I'll get to that, right? Why five you would want to select? Because there's a catch, right there. Why you need five, and I'll get to that. Start date. It is actually, this has been live from last Sunday, so the date is 9/17. There's no mergers, as I said. There's no team mergers allowed, so just none. The deadline is 11/26, which is just exactly a week before the end of your semester. Okay, so you have almost, just little more than 2 months to go through this competition, and it's a very simple data set. Probably you may have already used this before, just a hint, but there's some changes to it. We've kind of, just gone through and made some changes, little minor changes to the data set. So, just be a little careful here, and just go through some modeling, and not just based on your old data set, try to fudge anything here, because there have been some changes to it. Okay, so go through actual modeling, go through some actual testing, and submit it accordingly. Okay, so the competition scoring, so it's based on the submission file. The submission file has been provided. Now here's the catch: the submission file with the car ID and the class. Okay, so the submission file consists of two main pieces. It's car ID, and I'll go through the data set, okay, of what it is to be done, and we'll go through that. But basically, what I'm trying to point out is, whatever you submit until the last day, only 70% of that is really being tested out for your ranking. So let's say you keep submitting your code and your model, only 70% is going to be validated, right? So you would think that amongst your peers, amongst your classmates, you are at a particular score, at a particular rank, but the 30% of it really gets validated or tested or ranked on the last day of the competition, right? If everything is done, when the competition closes, the last 30% gets really tested out. So that's the catch, and that's why you would want to keep improving on as much as you can. And that's the reason why you would want to probably take up your last 5 best entries that you can think of. You can only keep one. That's up to you. So it doesn't have to be 5. You can keep only 1, 2, or 3, but maximum 5 entries. Okay? Any questions about the rules or anything that we covered so far? Okay? All right. So going back here, so thinking that, okay, I understand and accept all the rules. I click on this and I am in the computation, right? So now, once I see this, you've accepted the rules for the computation. I am part of this computation. So now, this my first page is the overview of the computation. It kind of tells you what this computation is about. It says it's a car evaluation database computation, and it just gives you some information about the source of the data, where this data is coming from. It just gives you some, past usage, some information about this whole data set here. That it consists of the, some car data set. It has some price information. It has got some technical characteristics information, and all that. So you can just read through this to get some, information about that. And we are acknowledging as to where this is coming from. So just making sure that we provide references about this data and where it is coming from. Okay, so just some acknowledgements here. All right, so that is one particular page. The second page here is about the data. So this is the area where you can download the data set. So the first data set is the cars train.csv file. It is a 33 KB data set, and this is the training set which you can use for training the model. Then there's the cars test.csv. You click here and you can download this. It can be used for testing only during your training phase. And then there is the cars sample submission. Now this is the sample submission file which is in the right format. Okay, this is the format that you should use to submit your this is the final file that you use for submission. Okay, and I'll show you the submission area. Now this provides the total rows that is required for submission. Now, and there are 2 fields that are required here. One is the car ID, and then and the other field is the what is the acceptance, right? What is whether the class of the car, whether it should be in the acceptable, unacceptable. There are this is the class of the car, right? It's the acceptability. So one or more car ID in this file may not be present in the about training and or test data. You see that? So this is very important to note here. Now there are certain cars in this submission file that your training data has never seen before. So you'll have to really train this model very well because it has not seen some data before. So this is going to be a good test for you, and hope you really enjoy this computation and really use this for practicing all your skills, practicing in everything here, and of course this particular interface as well, and also about Kaggle as well, because you'll see many other data sets here, and at some point you'll also be getting into Kaggle computations also. So this would be a good start for you, and also this is a pretty simple data set as compared to many other Kaggle computation data sets. So use it, and use this 2 months. I think this would be probably enough time for you to work on this particular data set. So this data set has got not many fields here. It has got class, car ID, it has the buying price, maintenance price, number of doors, capacity in number of persons, lug boot, and luggage boot, I'm sorry, and safety, estimated safety of the car. So just very few fields here, and that I believe there are not too many rows as well. So pretty simple data set from that perspective. Then there's also a discussion area. Now, I would say, use it wisely. You can come here to discuss about your topics, some of the areas, but I would probably say that, to use it wisely and do not try to, exchange solutions here or try to, just share any piece of code here. Okay, maybe you want to just share some of the ideas and thoughts, but do not just kind of share code or solutions or your any kernels or anything of that sort. Okay, so please keep away from that. Although you may have seen in other competitions people doing that, but that should not be this that should not be the reason for your discussion here. Okay, just simply keep it to talking about algorithms or your concepts or anything of that sort. So that's for the discussion board. The leaderboard is once you have submitted your file, um, and I'll show you the submission area. This is the area that will show you what your scoring is and how many entries you have submitted so far, and what's the last the entry here, the last submission that has been given here. And this is kind of showing you that the leaderboard is calculated with approximately 70% of your test data, and the final results will be based on the other 30%. Now, if you click on the private leaderboard, it will tell you that the private leaderboard will be available after the competition ends. So just letting you know that the 30% is not going to be calculated at this point. Once again, if you want to see the rules, you can see the rules again, which you have already accepted before you enter into this competition. Now, for the evaluation of this particular model, once you submit it, how does it get evaluated? It gives you all that information in this evaluation area here. It just tells you that in the model performance is based on the multi-class classification accuracy. Okay, so simple accuracy, and you can just go over it to it. I mean, it gives you some more information here as to how it's calculated, and probably you know about it as well. So pretty simple here, and this is the area where you would submit your predictions. So you come to this particular area, and you would upload your submission file. So it says here very clearly here your submission should be in a CSV format, and once you submit it, it is expecting the solution file to have 434 prediction codes. This file should have a header row, and you please see the sample submission file on the database. So it kind of gives you all the information that should help you to build that submission file and to upload it here correctly. But if any questions, you should just put it on the discussion board, and I'm sure Yelena or myself will definitely help you with it. Okay? Any questions? And yes, after you upload it, please click on this make submission to ensure that it's recorded. So once it's recorded, it will take you to this leaderboard, and it will show you this public leaderboard as to what your score is. And it will not just show you your score, it will also rank you against your classmates as to where you are at that point in time. So this will keep ranking you, this will keep showing you your score, and you may want to just keep improving upon, right? So this will kind of keep you, into, it's a nice, very healthy competition here. It will kind of just keep showing you where you are, how you want to keep improving upon it. You kind of keep competing against your own code. You kind of keep competing against your, your peers, your classmates, and it's kind of keep everything healthy, right? I mean, you want to kind of also keep talking to your, classmates about, how you've been trying to attack this problem, and about just without, sharing the solution. So At the same time, you may want to help your classmates with, how you've been attacking this problem, this concept-wise. Okay? Is everybody okay with this? All excited about it? Any questions? You guys think you'll be able to take on with the assignment here and get started soon? So the question is for the report, how detailed you should be. Do you mean the report for this one, or was it for the text assignment? Sarah, sorry, I missed the second part of your question. Let me get to that. Let me stop sharing my screen so it will be clear. Oh, for the assignment one. Okay. So Yelena, the question was how detailed the
Yes.
assignment.
Okay. Well, basically, you want to make sure that it addresses the key points, right? Because isn't there an explicit question on how to determine the key value, right? Well, like for instance, I see part of a question is an elbow plot, right? Well, you want to make sure that the answer actually covers the question. Uh, does it need to be in a report? Well, it depends on is it part one or is it part two? Which question are you referring to? Because basically, if you are answering the last question about the k value, right? Is there a question on how to on which approach do you use to determine to estimate the k value? Then yeah, the cluster plot. I'm sorry, the elbow plot is one of the possible answers. Then you need to actually discuss. No? Because see, it really depends on the paper structure, and it depends on the rest of the report content. But if you're discussing the results, if you're discussing some results on which your analysis are based on, then you have to have a copy of results somehow. And who is the audience? That's a good question. To be quite honest, the paper will be evaluated by instructor, but basically the audience is going to be just pretend it's your client, because you want to define the purpose of your study, and you are actually presenting the study results, right? Like in my case, I'm presenting the results. How would I determine if the message is in fact fraudulent? Which words appear together? And I'm using the results of my clustering algorithm just to say, hey, these terms seem to be together. Like if I go back to the slide, I think there is a copy here. Oops. Oh, it's because I'm not presenter at the moment. That's all right. But anyway, if you notice the plot, right, in my plot, I showed which terms appear in the same cluster, right? So basically, if I'm presenting it in alignment terms, I'm going to say that the method identified these terms appear together, that terms appear together. I'm not going to show the cluster centers, something like that. So, but it also depends on your study. There is no right or wrong answer. I would have to look at your study. Well, I hope I answered the question. But the thing is, for the DTM, there is a question about it, right? You want to explain its purpose. Then make sure that the answer addresses the key purpose of DTM, and some of it I discussed today, if not almost all of it. Right? Unless, did you hear me answer that question today? The DTM?
Yes, I did.
I mean, you heard I answered it, right?
Yes.
Yeah. So basically, you want to make sure you're addressing the key points and that the examples you use go beyond. So in other words, you're not just doing copy and paste the provided code and just run. You know what I'm saying? You want to add to it. You want to modify it. Yeah. Well, you want to reuse the code that's provided, but you want to go beyond and you want to customize it to your study. Like an example, you have a walkthrough on the code description, right? Here, I use a different text, and I was doing more in light of this specific text. So, I'm not sure if I answered the question. Or if there are any follow-up questions. Linesh, did I answer the question? I'm just trying to make sure because...
Yeah, I think so. I think Sarah also probably thought you did.
Okay. Well, yeah. More questions? Because if there are no more questions, what do we start doing, Linesh? We start
That's worse
asking.
because you start asking questions.
Yes. Exactly.
That's what I was going to tell everyone. Guys, start asking questions.
Yep. So everybody remembers when the assignment 1 is due, right? It's due on October 1st, promptly at 11:59. Well, okay. Oh, did I see another question? Did I see another
Someone heard
question?
me and started asking questions, which is good.
Who?
I thought, oh, okay. I thought somebody asked question. It was not really.
Is there a way to what? Protect the word cast? Okay, is there a way to, what is it, protect a word customer before running stemming? Oh, that's an excellent question.
Why
Protect.
can't I see that? Was that a private question to you? Maybe.
No, she sent it to everyone. Okay,
Oh,
because,
okay. Yep, I can see that now. Okay, yep.
yep. So basically, uh, well, the thing is, yeah, the question is protect. What does it mean, protect? So it's not chopped off? Oh, oh, I see. The customer will change to custom. It's because it's looking at the set of predefined roots. That's what it does. And it finds the predefined root custom. It will just think that er is a suffix. That's what it does.
Yeah, I think the way to kind of bring it back to its original form is if you
And
do a
complete.
stem completion.
Oh,
That
that's a good homework.
yeah, if you do the I mean, which not many kind of I mean follow that practice, but if you want some of these words to kind of come back to its original form, you can use a dictionary and kind of use the corpus. First, copy the corpus, and then use the same corpus and go through a stem completion. So you can just probably Google it or maybe just look at a stem completion format. It's also you can also look into the help in our studio, and you can look for stem completion, and it kind of shows you how to go through that step. But basically, it's just telling that saying that some of the words that you want to like this customer, if you want to get it back to its original form, you can.
Yeah. But this is the main drawback, that this approach does not actually look at the meaning. Yeah.
Yeah, I kind of had done something very
Yeah.
similar for some of the words. I'd actually stored it into a dictionary and then use that dictionary to kind of actually do as like a spell checker. I done a spell checker basically. Instead of doing a stem completion, I had a spell checker, and I used that spell checker to go through the corpus again to do correct those words. So that's another way to correct those words which you think that may have got messed up.
There are so many packages for text mining, so I'll give you guys a URL, because what we covered today may be only 100, if not thousands, of what's available there. But
Right. And I know there's a package for spell checker as well that you can use.
yep. So yeah, because we're not even looking at the term sentiment here. We're not looking at the sentence structures in those. It's a little subset. Oh. More questions? All right. More questions? I guess, Ilash, is there anything you would like to add about the text mining that I may have?
No, I think we pretty much covered it all. This was good. Do you feel the Kaggle will affect our in-class work? I think it should enhance your in-class work. What do you think, Elena?
Yeah, I think so. And in fact, this will give you the 3 points. So, for example, if your average course grade is 88, it's gonna give you an A because you get like 3 points. Oh, ability to time management. Oh, this is an excellent time management practice. Well, it depends how far in depth you want to go in a competition, but time management is an excellent key. Well, it's that's a good question actually. It's a good question to ask the students from last semester how much time they spent on this competition. But what if you do that? Perhaps you do the required work first, and if you have
Yeah,
time to do this.
true. And all I would say for any of these assignments and Kaggle competition, guys, I'll tell you from my own personal experience, and you'll see it in my bio as well. I've been a past student of data analytics program, UMAC, and and I'll tell you the fact that one of the reasons for being successful in this program has been that that all the assignments that I worked on, I started it right from the time I got the assignment, right? I mean, if it starts on week 2 or week 1, start from day 1, right? Start from the day you get the assignment. If you leave it to the last day, it never works out. Never. And any time that I ever did, I don't recall, but if I ever did, um, well, it always turned out to be that it was not a good experience. There's always something that happens at the on the last day, that weekend, right? Murphy's law strikes, right? If everything is going right, with your solution, maybe the website is down, maybe something's going wrong, right? So make sure that you get started on time, you get all your work done, and you start right from day 1. So even if this competition, right, don't knowing that it's there for 2 months, don't wait for a month to go by and then start with it. Just start with it. Just do as much as you can. Even if you have worked on a solution, get a solution to it within a few days time. Okay, fine. You got a solution, submit it. Maybe you submit another solution. That is 3 points, right? I mean, 3 points. Maybe just putting on a solution, you get 3 points. Why not? Just go for it. Put it in your kitty. Put it in your pocket, and then try to improve on. Try to keep improving on. That itself is going to give you an edge. That itself is going to help you with your other assignments, maybe because of the ideas that you will be getting from. So just is how I would kind of look at it from a time management perspective, and also how it may be helping. Just my 2 cents.
Yeah. What is it? Oh, the student says, I have opened the link but cannot see the join link.
Well, I'll be sending you the link, guys. So if you're trying to copy the link that I kind of was using it during this session, please do not do that. I will be sending the link out to you. Please use that link.
Mm-hmm. Yeah.
Yeah, the one that you may be using for data 650, that may be just a link to view the computation, which anybody can use to view it. It would not have the join button in there. There's a separate link to join the button, to join the computation, which I will be sharing on the discussion board. Okay, so you'll see that pretty soon, and you can then go in and use that link to join the computation.
And because I'll be posting this presentation, it's going to be on YouTube, and we don't want anyone else to, you know what I'm saying?
Right. No, I'll be posting that link. So
Yes.
just so you know.
Mm-hmm. Yeah, but those are excellent questions we got
Yeah,
today.
no, that was. I'm glad that someone asked that question. Yes, that's right.
Mm.
I think it was Mike. So Mike, thanks for asking that question. It was a great question, and thanks for trying that.
Yeah. Any else? Any more questions? More? I guess. If there are no more questions, do we call it a night?
I guess so.
Okay, I'm gonna end the recording, and thank you, Linesh, for introduction to Kaggle competition.
Right. Thank you.
All right, thank you, everybody.
And big thank you for covering last couple of weeks. Appreciate it.
My pleasure. All right. Talk
Okay.
to you
All right.
soon.
Thanks everyone,
Bye.
and good luck with the assignment and with the competition as well. And we'll see you in the class as well. Thank you.
Bye.
Okay. Good night. Bye.
Bye.